Good afternoon, everyone, and welcome to our joint Eloquence and Trust LLM webinar on Trustworthy AI in high-stakes applications. My name is Jelena, and I am part of the Eloquence communication and dissemination team, and I'll be your moderator for today's session. This session is designed to explore what it truly means to develop and deploy AI systems in environments where reliability, robustness, and human trust are critical, from decision-making processes to safety-sensitive domains. I'm very pleased to have with us today our two guest speakers, Petr Motlicek from ELOQUENCE project and Annika Simonsen representing the TrustLLM project. Before we begin, I have a few quick notes for you. This session will be recorded, and we kindly ask all of you to keep microphones muted unless you are invited to speak. Later on, we will have a Q&A session at the end, so feel free to drop your questions in the Zoom chat at any moment. And yeah, if you're joining from our sister project TrustLLM, welcome and thank you for being here. So we can officially kick things off, I would say. Like I said, our first speaker is Annika Simonsen, who is representing our Horizon Europe sister project TrustLLM. TrustLLM focuses on developing the next generation of European large language models that are designed to be trustworthy, transparent, multilingual, and aligned with European values, especially for underrepresented languages. Annika, thank you for being with us today. The floor is yours. You can share your screen and yeah.
Thank you. Thank you. Thank you for having me today. So yeah, can everyone see my slides?
Yes.
Great. So my name is Annika Simonsen, and I'm a PhD student at the University of Iceland. And my PhD is part of the TrustLLM project, where I'm researching LLM alignment, which is also sometimes referred to as post-training. Jelena, you just gave us an introduction about what TrustLLM is. I know there are some people here who know what TrustLLM is. I see Trina is here, used to be part of our project. Yeah, thank you for introducing TrustLLM. If you have any more questions about TrustLLM, you can ask me later. So when I heard that the theme today was Trustworthy AI and high stakes applications, I thought it would make a lot of sense to talk about this summer project that we worked on this summer, where we, in TrustLLM, we created a benchmark that measures how European the values are in your LLM. So let's see, here is a picture of the people who were working on this summer. So I am the short one in the pink, that's me. My supervisor is not on the picture, Hafstein Einarsson, also part of TrustLLM. The guy on the right, Dan from Alexandra Institute, he's also part of TrustLLM. He is the leader of the evaluation work package in TrustLLM. And he runs this leaderboard for LLMs that's called EuroEval. Maybe you know it. And then we had two researchers from the IT University of Copenhagen, Max and Rob. So why talk about this benchmark today? LLMs are being deployed everywhere, also in Europe, and they're used in all types of applications. And usually in these applications, we let these LLMs speak directly to users, and users speak directly to these applications. So they speak to the LLMs directly. So it's very important that we understand and know how LLMs are behaving when they're talking to our users. And in the European Union AI Act, it actually mandates that our AR systems, our LLMs need to be aligned with our values because we want our language technology to be culturally appropriate in Europe. How do we know if our LLMs are culturally appropriate? How do we know that their values are aligned with European values? At the time when we started this project, we did not know of any benchmark that measures how European the values are in your LLM. So that's why we decided to make one. So just very briefly, I'm assuming most of you are quite familiar with this topic, but if not, in previous work in this field, it has been shown that LLMs tend to have a bias. So LLMs tend to behave in quite a Western cultural pattern way. More specifically, they've been reported to act quite American. And there are studies that have shown that this happens regardless of what language you prompt them in, and also regardless of what type of data, what kind of language the data is in that it has been trained on. So this is something that we wanted to investigate further as well. But to make a benchmark that measures how European the values are of an LLM, we first have to define what European values are. So if you look at the official European Union definition, then European values are respect for human dignity, freedom, democracy, equality, the rule of law, and respect for human rights. But how would I actually go about measuring that in an LLM? Our solution was instead of just measuring the values based on this official definition of what European values are, instead, what we wanted to use was this survey data from real humans. There's a survey called the European Value Survey. That is a large-scale survey that's been ongoing since the 80s. And this is a survey that gets repeated every 9 years, where they go to almost all countries in Europe and they ask questions about people's beliefs and their politics and their values and attitudes. And in the latest edition of the survey, they collaborated with the World Value Survey. So in this newest version of the survey, we also have data from the rest of the world. So this is actually what we're going to be basing our benchmark on, is these survey answers from Europeans and people all over the world about their values. So here's sort of like our recipe for how we made our benchmark. It was 4 steps. So the 4 steps are, we took some survey data, we took the European Value Survey. There's a lot of people in that survey answering questions. And then we figured out a way to choose the best questions to put in our benchmark. Then we made a scoring model that scores how European the values are of the LLM. And then we tested 13 LLMs in 10 different languages using 3 different formats. And I don't have a lot of time today to go into detail, so I'll go through these steps quite briefly. So if you have questions about any specific step, we can take questions afterwards. So step 1, get some data. So we took the survey data from Europeans, actually from participants all over the world. There are a lot of participants. There are 93 countries participating, and out of those 93 countries, there are 23 European Union countries. And when you take this survey and you filter out everything that's just like what's your name and where do you live, you end up with 151 questions in the survey. And these are very, very broad questions. And then there's lots of different types of questions. Some of the questions are like, how important is God in your life? Or how justifiable is euthanasia? Or would you dislike having homosexuals as your neighbors? So there's a lot of different questions and a lot of people answering these questions. And so we decided to try to see if, instead of just using all these 151 questions in the benchmark and all of these hundreds of thousands of answers, could we just try to figure out a way to pick out just the questions that represent Europe the most? Is it even possible to come up with just a small set of questions where the Europeans' values are represented the most? But if I want to do that, then I first have to define what I think of as Europe. Because Europe, I think there are 44 countries that are recognized as being in Europe. I'm not sure, I think so. But in the European Value Survey, they have 37 of these countries. So these are the countries that are considered as European in the European Value Survey. If I make a UMAP plot, where I show how these European countries answer the questions in the European Value Survey, this is what it looks like. So on this UMAP plot, if two countries are close to each other on the plot, it means that they answered the survey questions similarly. If the countries are far apart, then they did not answer the questions similarly. And this is all of Europe. And as you can see, the countries are quite spread out. It's not like they all cluster nicely together in one ball and they all agree with each other. And some of the countries are in the corner by themselves and other countries are in another corner. This is not a surprise. I mean, I think what we already know about Europe is there's lots of different countries in Europe, lots of people with different types of values. It makes sense. But then we thought, what if we try to only look at countries, not just in Europe, but just the European Union? And these are the countries that are colored in blue. So if you just look at the blue ones, these are the countries in the European Union. They do cluster a little bit more closely together. So in our benchmark, that's why we decided to only consider the European Union. So in reality, our benchmark is not about European values, it's about European Union values. And it's just really hard to say that. It's a very long word. So yeah, these are the countries that are considered in our benchmark, the countries in the European Union that are included in the European Values Survey. I won't go into too much detail about this, but we had an optimization algorithm that we created that went through these 151 questions and filtered down until it found the questions where the EU countries agree with each other the most. So we found out what are the questions where the EU countries agree with each other the most, regardless of how the rest of the world answers, just the EU countries. And we ended up with 53 questions. So in theory, these are the 53 questions that represent EU values the most. And if you look at what kind of questions these are, it seems like what I saw the most was I mostly saw that countries in the European Union seem to agree on things like LGBTQ plus rights and also gender equality, so women's rights and that kind of thing seems to be quite topics that countries in the European Union agree on the most. But there was a lot more as well. It's very interesting to look at. So we have our 53 core questions for our benchmark. So how are we going to score the LLMs when they answer these questions? What we did is we trained a model. It's called a kernel density estimator. And we trained it just on the European Union answers. So we took the human answers to the survey questions from the European Union, just for these 53 questions. And what you have then is you have a model that learns how people from the European Union, how they pattern when they answer these 53 questions. Because there's going to be hundreds of thousands of answers and not everyone's going to answer every question exactly the same. So it learns how European Union members or people in the European Union, how they pattern when they answer these 53 questions. The model then generates a score, like an alignment score, that then essentially says the way the LLM answers the questions in this benchmark this is how European the values are in the answers. Here's another UMAP plot. So in this UMAP plot, you can see how people in the world answer the 53 questions. So the blue oblong shape, that's the European Union. People in the European Union are, and it's a bit of a long blob, but they are kind of together. And this is where they're situated. As you can see, there are parts of the world that fully overlap with the European Union. So Oceania, which is like Australia, New Zealand, the values in these countries almost fully overlap with the values in the European Union. And Anglo-America also basically fully overlaps. Because like something can be a value in the European Union, but also be a value in the other parts of the world. But as you can see, Europe outside of the European Union, which is the yellow circle, does not overlap a lot with the European Union. So yeah, as we suspected, there's a big difference between these countries. And yeah, so on. Okay, so we have our benchmark with the 53 questions. We have a model that scores an LLM on how it performs on this benchmark. Then we wanted to think about how are we going to ask the LLMs these survey questions? Because the humans, they were just giving questions like a person came into a room with them and sat with a piece of paper and then asked them questions, and then it was multiple choice. So it would be like, please say how important leisure time is in your life from a scale from 1 to 7, where 1 is not very important and 7 is very important. And then the human would say 1 or 2 or 7, and the other human would write it down. We could do this. We could ask an LLM just the questions exactly the same way as the humans got it. But it might be a bit strange to ask an LLM, please say how important leisure time is in your life, because an LLM does not have leisure time, as far as I know. So we thought that should we try to ask these questions to the LLM in different ways and see if it has an effect. So we tried to make a more realistic scenario of prompting the LLM. So the second method that we evaluate the models is we created this situational multiple choice, which would take the same questions as in traditional multiple choice, except we create these like real life scenarios. So instead of just saying, please say how important leisure time is in your life, we would say something like, I have received a job offer and it pays better than my old job, but I have longer work hours. So that means I wouldn't really have time for my leisure time. I wouldn't have time for my hobbies. What do you think I should do on a scale from 1 to 7? And then the model gets to answer that way. And then we also tried to do a very similar type, what we called a method that we call the situational sentence completion, which is the same. You give it the model a situational scenario. You say, I received a job offer with better pay but longer hours. But then you, instead of telling it to give you an answer from a scale from 1 to 7, you make it complete the sentence. So it would say, when I make this decision about whether to take the job, then to me, leisure time is, and then you give the model the options, important, not very important, a little bit important, and then you measure the probability of the model make or outputting that answer. So yeah, so in our study, we are looking at, does the model respond to our benchmark in different ways if we ask it in different ways? Here's a really, really big plot that shows the results because we tested 13 models. It's very big. If you just ignore everything and just look at the blue bars to begin with, the blue bars show how the models perform on our benchmark on a scale from 0% to 100%. So the score is 0% means not European at all, and 100% means 100% aligned with the European values. And the biggest performing model was GPT 4.1 Mini, and also a Llama model from, I believe it's from Finland, called Llama Poro. And Mistral is not far, Mistral European model as well, not far behind. Generally, the bigger models are performing more European than the smaller ones. We have some models that we maybe expected to perform more European than they did, like EuroLLM is quite low on is in the last place. Anyways, if you then look at the yellow bars, this is where we didn't just ask directly how important is leisure time in your life, but we tried to create a situation. The score suddenly just plummets down to the ground. And this is very strange. So it definitely shows that it matters how you ask the LLM. But this is is suspiciously low. Why does GPT 4.1 Mini score almost 100% with a traditional multiple choice, but then less than 20% when given a situational real life context scenario? It's almost like it's very suspiciously low, much worse than we thought it would be. If I actually take a look at like if I just look at the answers of the LLM, so what is exactly happening, it seems that there were some very specific reasons why the format had such a big impact. First of all, we have some questions in the benchmark that are these embodiment questions. So there are questions such as like, are you a member of this organization? And in traditional multiple choice, the model would say like no, because like as an LLM, I can't be a member of this organization. But then if we ask in a situational context, it would say yes. And then some of our questions have not like 7-point scale or 5-point scale, but are like a 10-point scale. So from a scale from 1 to 10, how do you answer this? And when asked in a situational way, the models tend to be quite extreme. So they pick like 1 or 10. But then when we ask in just traditional multiple choice, it was way more nuanced and more similar to how humans answered. So it would sometimes say 5 and sometimes 7. So these are definitely some of the like main culprits. If we take and manipulate specifically these answers, the score will go from like 12% to like 75. It has a really big effect. So all of the results I showed you so far are when you prompt the models in English. But what would happen if we prompt in other languages? So we tried prompting in these 10 EU languages. We did Danish, Dutch, English, Swedish, French, German, Italian, Portuguese, Spanish, and Swedish. So in this table, you see the 10 different languages. You see the alignment score of the GPT 4.1 mini and Llama Poro 70B, which is the Finnish model. And you see how European it scored on our benchmark. And very interestingly, GPT 4.1 mini did not score the most European when prompted in English. It actually scored the most European when prompted in Dutch and in Spanish. And Llama Poro just shows quite a lot of variation. Like there's a big difference in whether you prompt it in English or Dutch. It's very European, but then for some reason, like Danish and Swedish, it is very not very answering not in a very European way. So we tried to do some correlation analysis to see, is it maybe just because the model is just bad at that language? Is that why it's scoring so little European? But we didn't find any correlation between like the model's general NLP capabilities in that language and how it was aligned. So this means that like a model can be good at a language, like it can be good at a specific language, but it can be like good at Danish, but bad at Danish values, which are supposed to be European values. So just to sum up, we learned that how you ask an LLM a question has a big effect. I think if we just did the traditional multiple choice, we would have overestimated how aligned these models were. It was also important that we did it in different languages because we got different results. And for moving forward, we just think that we encourage people to think about how you evaluate models, because the way you do it has a big effect. And if we were to choose how you evaluate a model, we would suggest you should do it in a realistic way. You have to think about how do people actually use LLMs, how do they talk to them, and how do the LLMs then respond? And that's what you should use as your like your goal when you're evaluating how aligned the model is. And I just, thank you for your attention. And if you have any questions, I'll be very happy to answer them.
Thank you. Thank you, Annika, for this very interesting and insightful presentation and for giving us the closer look at how TrustLLM approaches trustworthy AI. Thank you. It was very interesting. Next, it is my pleasure to introduce Petr Motlicek from EDAP, who is representing the Eloquence project. Petr, we are happy to have you here with us today. Please go ahead, share your screen, and you can present.
Okay, let me try to share screen. How about now? Is it working well?
Yes.
Okay, great. So thanks. I will try to actually kind of make a link to the presentation of Annika. I think it will come rather later in this kind of talk. I don't want really to make it too long, and especially kind of focus then at kind of trustworthiness of AIs. But let me at the beginning to present maybe EDAP and me. So I'm actually from EDAP Research Institute, located in Switzerland. I'm partially also linked with Brno University of Technology in Czech Republic, and also I'm external lecturer at EPFL in Lausanne. So those two first partners, they are actually project partners in Eloquence, which I'm representing here today. The main background, as I have a PhD in voice technologies, is now focusing. So the background or the domain of interest is mainly voice intelligence, I would say. So what you can extract from the voice, from conversational speech, for various applications. So and this is also linked then to the language understanding. So eventually the voice is only one modality, and then it can be translated or transferred to text, and then there is actually a big part of how we understand actually the text, what we can extract from this and so on. And one of the important aspects of let's say my work is tech transfer of technology. So what I like doing, and also the team is partially working on this, is how we can transfer these technologies to end users, to industry eventually, because that's I think where also all these LMs are deployed and are being used by EU citizens, let's say, in our context. And we want to make sure that they are really working in the way we want them to work and so on. So in my case, the applications go towards civil security partially. It's mainly for law enforcement, air traffic navigation. This is like how to optimize let's say the planning and route planning of the flights to reduce the cost of them. Then there are forensic applications. They are very specific in a way how to answer the questions which are related to partially biometry or forensics. And then the big application, which is mainly linked to the eloquence, is like call center domain, where we try to plug technologies which can actually extract valuable information from the communication between customer agents, but also to use some kind of autonomous agents, let's say LLMs, on top of the data to help or support the customer agents, or especially agents in let's say resolving the calls in more optimized way. So in Eloquence, we are mainly working on Word Package 3, and more or less I described already actually the applicability. So we are the partner developing the technologies, so not only to try to evaluate them in the sense of how good or bad they are, but we are principally working on developing these AI machine learning technologies. And here in this short talk, I would like to actually to make a link between the achievements which we have. So maybe I'll just give some few examples of what we have and how these are actually linked to the deployment of those technologies to highly risky applications, what it means. And then looking closely on LM-based autonomous agents, I think this is starting to be a link to the project of Annika, through the kind of like building some kind of these LM agents and then evaluating them in, let's say, end-to-end fashion. So starting from the beginning to the end, what kind of task they are supposed to solve, and how we can evaluate that this task is correctly solved, or actually they are not actually doing the right job. And then the last point can be linked to open legal questions, or maybe trustworthiness partially, and something which is now happening on the EC side, European Commission side, which is so-called reality check consultations. So actually, the team itself at EDAP is quite large. These are people working with me. I'm not the only one, and I thought like it would be good to put them here as well. Um, so one of those technologies which we have developed is at least in the context of call center domain again is a framework which can automatically extract the dialogue flows. So the point is how we can understand that if there is some communication between two humans, let's say, the customer and agent, it follows the expected path or expected trajectory, which means that there are certain uh, let's say states which this communication is passing, and the main goal eventually is to provide some kind of feedback to, let's say, the manager of the agent or the call center domain, to understand that this communication or this dialogue has been correctly resolved, or the request from the customer was correctly resolved, in the sense of the customer is happy, customers obtain the information he was asked for, or there is actually another maybe instrument which needs to follow in order to actually resolve the issue which is there. So one of those technologies is called dialogue to flow kind of framework, which partially is actually looked here, and we are just simply on the example, or this figure below on the left side, we are showing that we have kind of better technology how we can map the textual information into some kind of embeddings, so-called embedding vectors, which are better follow the topics of the communication. So, which means they are better structured and they are more how to say they are better for following tasks. They are more qualitative in sense for following task. Like for example, we would like to detect the task was correctly resolved or not. One of the aspects which we are also doing is, and this is going to be seen on the next slide, is we are always also using this kind of technology for tasks which are not related to text processing, but we are going for different modalities, and this I may actually show directly here. One of the interesting points of these so-called LMs, let's say, as they're mainly used now for text processing, they're also very good actually in comprehending non-textual modalities. Uh, so even though they were not trained on like audio or visual modality, let's say, they are pretty good in being deployed for tasks like automatic speech recognition. So where the input is audio, the output is transcribed text, and these models are actually providing state-of-the-art performance. So this is one of our actual achievement, which in fact is going across Eloquence partners called SLAM architectures. And you can see it actually on the right picture below. So simply the input is a speech, and there's some kind of prompt, which of course is a textual prompt, which needs to be well defined. And eventually, there is some kind of encoder, which there are actually many encoders which are freely available, trained on lots of data, large corpora. And then eventually, the input is transferred through the embeddings extractors into these large language models. Like in this case, there is some kind of Vicona model, and this LM model is able to understand the audio itself. Let's say again in the context of the text processing, and it's able to actually answer the prompt, which is like transcribe the speech and give me the transcription to the output. Also, actually, one of the technologies or interesting point was how we can deal with lots of data for, let's say, AI applications. So typical situation or use case for the companies, industries, is that they are not really worrying about the amounts of the data, because the data is there. They have access to the data from customers, whether it is text, speech, videos, and so on. There is enormous amount of the data everywhere around. The typical problem is that this data is not manually verified, not corrected, not transcribed, and there is, of course, still the processing, how to say, problem, how we can use this data for improving the models. So some of the works which we have actually done over the last 1-2 years was how we can actually filter the data which is available for the on the customer side or on the industrial side, in a sense that we select only those which are of good quality, in a sense of improving the target task. In this case, it was actually again automatic speech recognition task, so that you can do it also in an iterative way, and you don't need to have a label. So you don't need really to know whether the data is not manually transcribed, and we even don't need to have these transcriptions. And this is, in fact, again, going towards so-called these LMs, which are pre-trained on large amounts of textual data. And this data may be very noisy as well, in a sense that no one is able to verify the quality of the data being used for training. And this is one of the actually fact which is why these models are so good, because they have seen so much data. So we are actually applying the some kind of trick or some kind of frameworks for not for large language models, but for something which is more towards again understanding the speech signals here. And actually, the last point, which I think I wanted to mainly focus, and it goes from DDAP in as an ongoing work, which started actually at the JSALT workshop in summer, which is actually US European workshop between the researchers from the both kind of territories, running for more than 1 month. This time it was actually it was running on the Brno University of Technology, which with more than 100 researchers, let's say, students, master students, PhDs, and also industrial partners. And one of our actually goal was actually to, and this is already actually the outcome of this workshop, is to create the toolkit which can build and simulate and evaluate LM-based conversational agents. So something which people use in a way to communicate or communicate with autonomous agents, with the machine, to ask questions, to get proper answers. And our idea is actually to have some kind of framework or tool which is able to build it. We can simulate some kind of dialogues, typical use cases in the way of, let's say, medical domain, or in the domain of, again, call centers, where we know that there are these customers with these kind of requests, and there are those agents which have this type of information. We want to simulate it, but we also want to evaluate in the way that these models, these LM-based agents, are able to provide or behave in the way we expect that. So we call it like kind of model behavior analysis and mechanistic interpretability. So I can give maybe more examples on next slide, but this already goes towards something which I wanted to mainly speak about, which is how we define high-risk applications, because again, our kind of motivation is that we want to mainly support with our technologies developed in Eloquence to support human machine kind of teaming in the way that the machine is not going to replace the humans, but it's going to actually support it in taking correct or right decisions and so on. So, but again, starting from the beginning, we know, and this is a case for a long time, and this didn't really change much. We know that AI technologies, whether these are LMs or any other machine learning models, they produce errors. We are aware of that on the research side or development side, but it's not always clearly perceived by users, I would say, in the way that they trust the output very much. And again, we are trying to look at actually what, at least in my way, it's nice to look at things which simply are related to what humans are doing. So we are pretty good in, as humans, to detect that some tasks are difficult. There are actually some of the data in which are collected in situations which are very complex in the sense of the quality of the data, let's say, the sensory quality and so on. Example is recognizing the faces, like the people who are actually approaching to the humans. We are probably good in that if there are good light conditions. If I don't see and I cannot use my eyes, I'm not going to trust to something which actually is not able to provide good information, and I may start using different modalities for that. So, and this is what the machine is not able to do at this moment. So here I'm actually showing some of the application for these high risky cases. So in a case of eloquence, we are focusing on medical domain partially, medical support on interpreting. And this is one of the case which people are especially using the AI for, like to interpret complex images, MRI scans, and so on, where the machine can be very strong, very good in detecting some kind of specific patterns, let's say in these images, while probably the human may miss some important aspects of that. But and eventually there is still the human who is going to actually translate these into some kind of final report, because again the machine may make an error. The second one, which is especially interesting for us, and that's also related to higher risk applications, like how we can actually process large amounts of the data. It doesn't matter which data it is. In our case, it is mainly again audio and textual documents for law enforcement. So if now you look at civil security and at big cases which are related to any of the criminal kind of behaviors, there is a lot of data which is actually typically involved in these criminal investigations. And then at this moment, most of these analysis of this data is done by humans. So again, we don't want to actually replace the humans, but we want to support them with those technologies which are of good quality, let's say, who are trustworthy in sense of processing this data and extracting some of the evidence. But eventually, there is again human who is going to interpret it. The last actually kind of use case for us is, for example, air traffic navigation. I already mentioned it. The point is how to better optimize the airspace where the planes are actually typically needs to land. They need to actually follow some kind of sequence. And again, at this moment, majority of the work is done by the humans, but the machine can be very effective in some of the aspects of this. And this is actually mainly where we were looking into the deployment of our models. But then if I go again for the high risk applications, as I mentioned, uh, the humans are extremely good in recognizing, for example, rare classes a priori, which are a priori known. We know that there might be something which I don't know, but I'm able to recognize something like let's say the object which is not following to anything which I have seen before. The machine is going to fail on that. And this is something which I think the researchers are really working on, how to actually increase, let's say, the confidence of these techniques, especially for the cases where the machine cannot answer, right? So it's not going to hallucinate, it's not going to answer something which is probably very of low probability, and rather say, no, I don't know, actually the answer, than actually providing the wrong answer. So in terms of LLMs, actually, again, I mentioned it, we are trying to look at something where the LLM can be evaluated as end-to-end in end-to-end fashion. So I'm trying to point here that the LLMs at this moment, at least from my view as a citizen, are the main product of artificial intelligence now, because everyone knows about that. Majority of citizens are using this. But the problem of these models are that they are neither artificial nor intelligent, in the sense that they are not artificial because we are training them on the real data. The data is always actually of all these models, whether it is Llama or GPT, these are real data, extremely large amount of the real data which goes into these models, and they are not intelligent in the sense that they cannot actually reason. They cannot really provide full understanding, because these are still statistical models. But again, the people don't know about that, and they take it as a possible factual information which can come from that. So the question is actually how we can actually deal with that. We still, at this moment, we see these models as black boxes. This is for the researchers the case, even though we know the, let's say, the framework or the architecture of these models. But in majority of the cases, we don't know on which data they were trained, whether in many cases, we even don't know actually what kind of criteria for training were used. So it's still kind of black box for us. And especially, this is the main issue now, right, for with respect to AI Act. that the power of these models come really from the amounts of the data being used for their training. So is this acceptable in long term or not? And I would say the majority of industrial partners simply accept it in the sense that they know their quality, or not quality, but their power is so big at this moment that they rather actually go for this power than actually looking at some kind of consequences which are legal or ethical. And again, the question is it acceptable for long term or not? So what we want to do, and this is actually, I'm now focusing towards, again, the trustworthiness of the model. We have actually now, we are working on something called S-Dialog tool, which tries to simulate or evaluate these LM-based conversational agents, but in end-to-end. So we don't care much about how these models were trained, because we cannot actually influence it. We cannot even influence actually the data being used for training and so on. But we want to make sure that these models are performing in end-to-end fashion in the way we want them. So for example, LLMs are natively supporting function callings. So we are able actually to use the agents in the way that we only tell them that they should actually use several set of functions which are clearly defined, which you may see on this image below, and they are supposed to use only these functions to answer your question. And this is actually what is now being implemented for our kind of use cases. So for example, for the law enforcement agencies, here there is this one kind of demo which simply shows that the agent, which is a machine, is only able to answer the questions like, give me the person name which is already stored in your local database, but you should not hallucinate. You should not tell me that this name may be different, because you simply may find it in other data. So simply the model is structured in the way that it can only reach the data through the set of the functions. And then the point is that we want to build actually, so well, that's last slide, but we want to actually build these agents in the way that they are able to actually to work with this set of functions. And these functions are those which are supposed to respond to the request of the end users. And we are able, through again this platform, we are able to measure the correctness of the information which is sent back to the user. So eventually this kind of ongoing technology building, which we are running as part of Eloquence, is supposed to be able to verify that certain LM agents are actually working in the way we define them to work. So they are supposed to be trustworthy, even though we actually don't evaluate them in the sense of the building of LMs and what type of data is being used. So we look at that as from end-to-end problem, let's say. And eventually, there is also actually some kind of ongoing discussion, let's say, or consultation, which is pretty actually recent on the EC level, which is called reality check. And this is again linked to the legal issues, let's say, or ethical issues, I would say, in my eyes, towards what actually how the AI technologies are being used. So here you may see the consultation is supposed to gather technical feedback to ensure these EU policies, including AI Act, are actually practical and can be implemented with minimal administrative burdens, which means that the EC is aware that the models or the technologies which we are or the citizens are using are not coming mostly from the European Union. They are actually developed in other countries where simply they are not following the same kind of regulations. And I think the question is how we can actually to maybe to reduce these regulations in the way that, or simplify them in the way that actually these technologies can be more effective. So the outcome of this is the feedback collected by, let's say, all stakeholders, provided to commission and eventually to update and revise legislations. Whether this is going to happen or not, I don't know, but at least this discussion has already started there. I have seen at this moment, let's say, four directions of these discussions. One is for energy production, one is for aviation safety, which I partially mentioned, but there is also something which is related especially to digital regulation, which I think is related to, again, use of these autonomous agents for given tasks and how this could be regulated in sense of AI Act and so on. And again, this is mainly related to high-risk application, I would say. All right, so that's probably all from my side. I'll stop here.
Thank you, Petr, for this presentation. It was quite interesting. We will now move to the Q&A session of this webinar. This part we like to call Webcafé. So you're welcome to raise your hand or type in your questions in the chat box. If there are no immediate questions, I have a couple of questions prepared for our speakers to start the discussion. So, Annika, you first. So, trustworthiness in LLMs is such a broad concept. In your view, which dimension, safety, transparency, bias mitigation, or multilingual robustness, is currently the most challenging for high stakes applications and why?
That's a great question. And you could answer that in many different ways. So in TrustLLM, so we are 11 institutions in lots of different countries working together. I think we're around 80 people working in TrustLLM, and we are approaching this task of creating trustworthiness in LLMs from lots of different angles. So one way that we are working with this is we are trying to see how we can make models more factual. Because one way to think of how to trust LLMs is, of course, we don't want them to hallucinate. We don't want them to make up things. So how do we make an LLM more factual so we can trust it? This is, of course, a very difficult thing to do. And I don't, as Petr said, I don't think anyone has figured out how to do this properly with LLMs yet. Yet the thing is, as Petr said, that people are still using LLMs and trusting them exactly how they are working right now. So to us, of course, it would be excellent if we could make LLMs that wouldn't hallucinate and wouldn't make up facts. Because, I mean, there are just so many scenarios where you would think, I mean, we already have cases right now in real world where, unfortunately, people have ended their lives after speaking to LLMs. We have lots, not lots, but there have been a few cases already. So people are using LLMs as psychiatrists, chatbots to ask them for advice about their life, and this can end very, very tragically. So whether it be using LLMs for like for high stakes applications, as in with machinery or all sort of that thing. I mean, with people, I think it's also can be high stakes because people are speaking to these LLMs. I mean, another thing that I think is high stakes is I want the LLM to be able to speak my language. So in TrustLLM, we focus a lot on the languages. We are only focusing on the Germanic languages at the moment. And we want to make sure that the LLMs we make are good at the high resource Germanic languages and the low resource Germanic languages. So I come from the Faroe Islands. It's a very small country. It's actually part of the Danish kingdom, and we speak a Germanic language called Faroese, has 50,000 speakers. At the moment, there are no open LLMs that are able to generate our language properly. And this is also a type of well, inequality and injustice in the current LLMs is that if you don't speak one of these high resource languages, you don't get included in in the LLM space. And we are also seeing that like the model will behave differently if you ask it. People often say that like if you prompt it in English, it will work better. And this is, to me, not acceptable at all. So that was a very all over the place answer to your question. Um,
No,
but yeah.
it was great. I have one more for you.
Mhm.
What have been the biggest challenges or maybe surprises when ensuring equal performance and fairness across these languages?
Well, so the one thing that comes to mind right away is that unfortunately, well, first of all, the thing is we are focusing on one language family because the idea is that if you train a model on one language family, you can take advantage of this thing called transfer learning, where a model will maybe be trained on German and Swedish, and then that will teach it a bit about Danish as well. And we were kind of hoping that this would solve the problem for the small languages. But sometimes it seems that this can actually be more of a curse than a blessing. So for the very small languages, such as Faroese, this is not helping at all. The problem is there's another Germanic language which is very similar to Faroese. It's called Icelandic. And Icelandic is still a small language, but it's not as small as Faroese. And currently, models just don't want to learn Faroese at all because they think that Faroese is just a badly spelled version of Icelandic. And this is also happening for Danish and Norwegian. So Danish and Norwegian of LLMs tend to mix them up a lot because they're written very similarly. Um, Anything else? Well, of course, like our biggest problem with data at the moment is that we don't want to do what the big tech companies are doing. We don't want to train on copyrighted text. And this is a problem everyone is facing. And if you're not gonna use copyrighted text, then you don't have a lot of text to train on at all. And this has basically been like our number one obstacle in TrustLLM. And this relates to everything we do, because if you don't have data to train on, then you don't have a model. This is something we struggle with. I mean, we knew that it was going to be a problem, but we didn't know it was going to be a problem to this extent.
Thank you. Thank you. Great answer. Thank you. Petr. Eloquence aims to build multilingual bias controlled conversational AI. From your research so far, where do you see the biggest risks when deploying conversational AI in high stakes environments?
That's That's a difficult question. So I think, well, in eloquence, we try to target it, of course. The one of again the main I think domain of interest was this medical domain. So um, to support, let's say, doctors in answering kind of questions to the patients, which in my eyes is high risk application, of course. But again, it's high risky in a sense that the machine, of course, should not make an error. But we are covering that with this kind of human machine teaming. That again, there is still the human who is supposed to take the final decision, right? But again, we know that these models, and there is so far nothing better than that, is that they are statistical based. So they are probably going to perform very well for given scenarios, given domain where there is lots of data, good data for training, but they are not going to perform so well for our domains, like languages, for example. So there are still people looking at things like low resource languages, even though it sounds maybe odd at this moment. And maybe it is not really so much the case for Europe, even though Annika mentioned yes. But if you go to India, there are, thousands of languages. I don't know how many actually even, many people speak to those languages, right? Millions of people. So again, they are trying to target it, especially by collecting data from those domains. So again, I think the point is that we need to find the level of securing that these models are able to provide an answer which means I don't know instead of hallucinating. On the other side, and that's what many people do. So some of our colleagues, which are actually not really this is not related to eloquence, I would say, they are looking at prompting. So how, for example, you take the LLM, which is again the black box, and you are trying to prompt it in many different ways, in the sense to understand that if I provide similar prompt for the humans, but actually the prompt itself is different because the input is different, it should answer in the same way. And if you see that the model is not answering the same way, then you say, "Oh, well, it's not stable model. It's not the model which you can trust so much." So this is related to the explainability of the LMs. But again, on our side, we are also dealing with the issue of the data and so on. So we know we will probably not be able to replace these models, at least not in a very early stages now on European sides, to replace GPT model by some European level model, which is going to be legally compliant, even though there are such achievements or activities. But people are going for the quality, and again, quality is related to amount of the data, even though this data is having the privacy issues, but how we can actually control that, right? So that's why at least our kind of direction in eloquence, and this is especially again on EDAP side, but I think this is already partially accepted on eloquence as a consortium, is trying to look at the problem from end to end. So you start with you take the model, you try to apply, or this autonomous agent, you try to put it into given kind of scenario, which is, for example, medical domain or this call center domain, trying to simulate this through the data, because there are technologies which we have in eloquence which can generate lots of synthetic data, lots of synthetic dialogue, let's say, which are very close to the reality, I would say. And we are trying now to measure with respect to this model, type of model, and this data, to evaluate how actually this model is able to answer or to behave with respect to the tasks which are given to them. And then we can say this is actually here we see it fails because of, and we can measure actually where it fails and why it is failing. So this again is my eyes something quite interesting. It's called like interpretability of the model, but we are not really looking into how this model is built and what kind of data is being used. And of course, then eventually going back to your question, this is related to high risk applications. So if we know that for certain domains and these type of models, this type of large language model, like Anita has mentioned or shown, right? There are so many models now being accessible. Some models are definitely better for given tasks than some others, but vice versa, maybe they have more problems in different tasks. So you can measure which model is better for my task, for my language, let's say, and scenario than some other model, and measuring it on the concrete task, on the final task.
Okay, I have one more question for you, probably a tough one as well. How do you think we can practically strengthen the trust in AI? Sh- should we add some more regulation, maybe better data sets, or something else? What do you think?
Well, probably the data itself will not be an issue. I think, again, trying to for example, if you are in a company, let's assume I want to actually use some technologies in a company as a in industry, and of course I'm providing this to the customers, right? I want to make sure that this technology which I am actually sharing with them or I'm providing to them, it performs in certain quality, right? But on the other side, you don't want to stop on improving these systems or improving these technologies, because then again the concurrence is there. So if you now say, well, my model is the best and I don't need to do anything for next 10 years, probably this is not going to be the case, and someone is going to come with a better solution which is going to be more robust or more performant in quality than me. So they need to kind of still improve, or how to say, like adapt the technologies towards the better qualities. And the question is how you can do it, right? So you want to find, for example, some kind of iterative approach, which simply includes, of course, new data, for example. Why not? That's, of course, the case because the data is always being collected. more and more data is there. But also you want to have certain assurance that this new model is better or at least as good as the previous one. So some kind of unit test, but again, we go back to the evaluations, I would say. What else we can do? So trying to evaluate these models in the sense on concrete tasks, on concrete data, and this needs to be probably continuous because eventually you may have different tasks, different customers, and so on. So I don't know what else at this moment can be really done to increase the trustworthiness. Eventually, would like to have something like the synthetic human, or let's say the something which really follows some kind of human qualities in sense of at least detecting anomalies in the data or detecting something which simply is out of my knowledge and saying at this moment the answer is not possible to provide because I don't know about it and the models are not good in this. And so far, I don't see anything which would be able to actually resolve this problem. Right? And this is related to trustworthiness eventually, right? I don't need to have a machine which is perfect. I just need to have a machine which is able to provide accurate information when it can, but not when it cannot.
Great. Thank you. If there aren't any questions from our audience, we can close this session. Thank you both, Annika and Petr, for your excellent presentations, and big thanks to everyone here for joining us today. A few quick closing notes from my side. The recording of this webinar will be shared across our social media channels. Also, feel free to follow both Eloquence and Trust LLM on LinkedIn and other social media. And yes, on behalf of both projects, thank you again for your time, your engagement, and for your interest in Trustworthy AI. I'm wishing you all a great afternoon and until next time.
Thank you.
Thank you. Bye.
Thank
Bye.
you. Bye, everyone.